In this next section, we're going to discuss reaction rates. Since enzymes are proteins and protein functions are sensitive to their environments, enzymes are affected by their environments. Factors affecting enzyme activity are temperature, pH, salts or ions, and other chemicals. Effect of temperature on enzymes. In general, increasing the temperature of a system increases the reaction rate because the substrates are able to move faster and have more collisions with the active sites of the enzymes. This is true only up to a specific temperature, the optimal temperature, and is unique to each type of enzyme. So you can see here, as temperature increases, the rate of reaction increases. We're maximizing our production up to some optimal temperature. But if we continue to increase the temperature, then the enzyme will no longer be stable. It can denature, and the rate of reaction will then quickly decrease. Past the optimal temperature, the enzyme begins to denature or lose its shape, which changes the shape of the active site. Enzyme denaturation affects the secondary, tertiary, and quaternary structures of an enzyme. So if this is our active site at optimal temperature, which perfectly fits our substrate here, beyond the optimal temperature, this active site is now denatured. It can no longer hold its shape, and the substrate no longer fits. Depending on the severity of the temperature change, an enzyme may become permanently or temporarily denatured. Under certain conditions, enzymes may be able to regain their function after returning to an optimal temperature. Let's take this example in A of an active protein. If we increase the heat, we denature it and we have an inactive protein, and no reconfiguration is possible once we then lower the temperature down to the optimal temperature again. So it's permanently denatured. That happens when we fry an egg. We permanently change those proteins. But in the second example, if we do the same thing where we heat beyond the optimal temperature, denature the protein, and then we return the temperature back to the optimal temperature, we can reconfigure that temporarily denatured protein. And that can happen when we warm milk. Fever is the elevation of body temperature above normal. In humans, normal is 37.2 degrees Celsius. Typically, fevers develop in response to bacterial or viral infection. The optimal temperature for most bacterial enzymes is less than 37 degrees Celsius. So, by raising body temperature above that, the immune system attempts to denature the bacteria's enzymes and stop the infection. Common enzymes. Laundry detergents contain enzymes that help break up and remove stains. Why might you want to use a different laundry detergent when you wash clothes in hot water instead of cold water, leading to these two different kinds of laundry detergent? Effect of pH on enzymes. pH is a measure of the extent to which something is acidic or basic, with pH 7 being neutral. You can see here at pH 7 we have pure water. Most biological solutions have pH values between 6 and 8. You can see circled blood, healthy human saliva. pH levels that vary from the optimal for a particular enzyme can also cause it to become denatured. The optimal pH for most enzymes is between 6 and 8, but the optimal pH is different for each type of enzyme. So this enzyme, we have the relative rate of enzyme action. As the pH increases, we see it increases and then decreases, and this is the optimal pH for this enzyme at 4.2. Cofactors. Sometimes enzymes need a helper to bind at the active site to make the enzyme active. These helpers are called cofactors. Essential dietary minerals are often cofactors. If the cofactors are organic molecules, then they are called coenzymes. Vitamins are usually coenzymes.